Okay, so here we go. I'm going to take a look here at decision matrix and what these are. So you can refer back to these on the Google Classroom if you want to. So we're going to develop a decision matrix. Now, by the way, I used these when I worked in industry. I also use these as I haven't done one in a little bit, but as of last May, I decided to buy a new pickup truck and I wanted particular features on the truck. So what I did is I set up a decision matrix with my ideas were Ford, Chevrolet, and Ram. There were only three choices. That would have been in the left-hand column where they have the word cost here. And then across the top, I would put down the things like the features that I wanted. 12-inch touch screen for the truck, cost of the vehicle, leather seats, satellite radio, power steering, power windows, those kinds of things would go across the top of this. And then what I did is I would rank 1 through 4, with 4 being the best. Okay. So if the cost was low on the truck, it got a 4. If it was the most expensive one, it got a 1. If a particular trim level had, actually I did 2 decision matrices because first one was an overall to decide between Ford, Chevy, and Ram. And then the second one was once I decided on which one of those trucks I wanted to buy, then I had to decide on the different trim levels because there's like 4 or 5 trim levels at least for Rams. Ram was what I decided to buy, a pickup truck from Dodge called a Ram. So anyways, this is what a decision matrix is. It's used to compare design solutions against one another, and you use specific criteria that are often based on project requirements. So here is identifying some ideas or alternatives. So what material would be best for creating models of puzzle pieces? Remember we did our puzzle project and we used wooden blocks for ours, but here we're going to go through and decide what is the best material for making models of puzzle pieces. So the first thing is modeling clay. Well, here's the benefits of modeling clay. It's reusable, readily available. It requires you to form it. It is sticky. That might be a deficit, right? And it gives you imprecise geometry. Idea number 2 is caramel cubes. So apparently this is candy. Well, let's talk about that. It's cheap. It's readily available. It is already shaped. You don't have to mold it at all. Deficit, it's sticky. And again, it's imprecise because you could have one that might be, 50 thousandths of an inch smaller than the other. Dice, all right. Here's a deficit to dice. They're expensive. They're reusable, so that's a good thing. They do require you to put them together with something like a glue or 2-sided tape. They're stable. They don't grow and bigger or smaller. Clay would probably shrink or whatever as time went on and it dehydrated. They're stable and they are very precise. They're all going to be the right size, hopefully. Then we have centimeter cubes. Those are the little ones that snap together. They're cheap. They're reusable. They do interlock, so they'll stay together easily. There is little protrusions sticking out of them, so that might not be a good thing depending on what you're making. And they do have some very precise geometry, though. Then we have foam blocks. Well, foam blocks are expensive. They are reusable. They require 2-sided tape to put them together. It falls apart easily. And again, the geometry isn't very stable. It's imprecise. Then we, of course, sugar cubes. They're cheap. They're readily available. You're going to have to glue them together. So that might be a problem. They're also going to kind of disintegrate a little bit. So they have messy granules, and they're fairly uniform in geometry though. So identifying criteria. So these are the 5 things, or 6, or what do they got here? 3, 6, 7. These are the 7 things that they're going to put across the top of this chart. Cost, reusability, geometry, connections, cleanliness, reliance, and testability. Other criteria that you could use. So maybe some of these may apply to your decision matrices. Function, lifespan, development time, size, material costs, development costs, manufacturing costs, company standards, manufacturing capabilities, safety. Those are all different criteria that might be usable for you on your decision matrix. So you're going to develop that decision matrix, and you're going to use a grading scale to assign values for each criteria category. So you come up with a ranking scale. 4 in this case is going to be the best. 1 is the worst. If it's a question, it's a yes or no. 2 for a yes, 1 for a no. So here's the chart that they created, okay? And you'll see on the left-hand side, here's all of our ideas. Modeling clay, caramel cubes, dice, so on. And then across the top are the criteria. They've got 1, 2, 3, 4, 5, 6, 7. You only have to have 5. Remember that. You have to have 5 of these, then 5 different ideas. And then you have a column here for totals. So we're going to start going through this. So they start by choosing the cost. And they say that the cost of modeling clay is not the worst, but it's low. And then we have caramel cubes. Those are a 3 for cost. We have dice. That's a 1. Dice are expensive, so that gets the worst score. Interlocking centimeter cubes, those are pretty inexpensive, so we have a 4 for that. Foam cubes are costly, like we saw in that little list next to the name. And then we have sugar cubes at a 4 because they aren't very expensive either. Then reusability, they go through the same thing. And you'll notice it's not ranked against each other. It's just ranked against what's the worst, what's a high cost, or is it reusable? If it's not reusable, then it's going to get a 1. That would be like sugar cubes. If it's highly reusable, I would think that these, this is a question. I'm sorry. That's why the question mark is there, Mr. Stewart. And that's a yes, no. And actually, if we take a look across here, these are going to be, I would have thought that this one would be a question because they had a question mark there, but they've got some 4s and 3s. So you go across, and this is how you set all these things up. Now, once you got that done, then you add it up straight across. So what's got the best score? Well, modeling clay is a 10, caramel cubes are a 12, dice are 17, the interlocking centimeter cubes are 22s, foam cubes are 14, and sugar cubes are 17. So what's the best one? One with the highest score. So number 4 is the right decision. So design decision should be based on analysis and logic, not that personal opinion that we talked about a little bit at the beginning. The decision matrix is a tool that can be used multiple times throughout a design process. So that's a decision matrix, okay? And what it is and how you're going to set it up. Now, I'm going to show you back on the Google Classroom here, as long as I can find it. Here we go. All right. On the Google Classroom, when you scroll down here, you're going to see that there is a decision matrix template attached to this. So it's got 1, 2, 3, 4, 5. It's got 6 columns here, and it's got 1, 2, 3, 4, 5, 6 rows. So you only have to have 5 and 5. But you can print this out and create this matrix for yourself. Would you like me to print it right now for you? 6. Well, why don't I do that? So I'll, here we go. Copies 4, 5, 6. Whoops. Okay. And I'll hit print, and we'll get that cranking. Don't let me forget to give you that on your way out. All right, now back to here. So we'll have gotten our brainstorming done. We'll have gotten our criteria set up and all that stuff. And we'll have done step number 1 completely here. Now, when we get done with step number 1, the decision matrix, we're going to have a design that we think is our best one. And it's time to develop the solution. So you're going to make, in your engineering notebooks, a neat hand drawing on graph paper that includes dimensions. On that page, you're going to explain 3 elements and 3 principles of design as footnotes. So we're going to use this PowerPoint here to do this elements and principles of design. We won't get through this entire presentation today by the end of class, but we'll get through the most of it. I want to show you what this is going to look like. All right. So this is my design, all right, that I've created. And I'll move this down. See, I've got a top view up here. Okay, that's the material. And then this is the design of my my plate, my nameplate, and I've got a graphic on here, and as all I did was I went on Google, and I did a Google search for fly fisherman because I like to fly fish. It was something my dad and I used to do. Anyways, so I put a little bit of a graphic on here, and you can do that with our project. We're going to put, remember, something that should be something that shows a little bit of what you're interested in on your nameplate. So we're going to be able to cut the nameplate out, and then we're going to be able to etch in a design like this. So I just printed that out and sized it up and cut it out and put it on my piece of paper. So if you find something like that, make sure you save the image too, okay? All right. Now, so 3 design elements and concepts of design. That's what you have to write. So that is down here. So you'll see these in a couple minutes, but I use a horizontal line, contour shape to represent calm, peace, and relaxation. I'm going to use the cool color blue for my nameplate. That's going to add to the contrast between the foot of the nameplate color. So I'm going to have the little stands be a different color, so that's going to give me contrast. I'm going to leave negative space above the name to add character and seem less busy. And then the proportion of the logo will be the same as the name. And then we're going to use less space is going to create what we call an economy of design. That's going to allow me to obtain more with less in my design. So you have to handwrite out neatly, by the way, so that I can understand it or read it. I'm going to spend exactly 1 second trying to read what you wrote. And if I can't read what you wrote, guess what? It's just no good. I suppose what you could do, if you know your handwriting isn't that great, you could type this out and then cut out the page and tape it into your notebook. That would be fine also. So that's just a good way to go. All right. So let's start the elements and principles of design PowerPoint. All right, see, here we go. All right, so elements and principles of design. And again, the PowerPoint is attached to the Google Classroom so that you can easily take a look at this. So there are 8 components used in the creation of a design. They're all right here. I'm not going to list them off because we're going to see them in just a second, but points and lines and so on. All right. So a point. Points are the most basic element of design. A point has a position, but it doesn't have a dimension. It's just a dot. It can be described by coordinates on a plane, and it can be used to indicate a location. Lines, well, they have a length dimension only. They can be used to define a boundary, to indicate a volume of something, to suggest movement, to employ a motion. They can be used to create perspective and depth, and they can be used to create textures and patterns. If you take a look at this picture here, right, this is a perspective. As it goes back, it kind of squeezes in from the left and from the right-hand side, kind of goes back a little bit into the woods there. Vertical lines characterize dignity, formality, stability, and strength. This is, a typical lamp that you might see. And of course, here's a typical school building. It happens to be our middle school. And then we've got this back plate or this cover on a cell phone of some sort or another. Horizontal lines give you calm, peace, relaxation to you. So that's the reason that buildings have vertical and horizontal lines. All right. So here's an example, like with our high school, of a pretty strong series of horizontal lines. You can also see these things in furniture design in houses. Diagonal lines have a sense of movement and action and activity. When I look at that cup down there in the lower left corner and that pattern that it has on it, it kind of like fuzzes my eyes out a little bit, I guess. I don't know how else to describe it. Apparently, this thing in the upper right-hand side is a Bluetooth speaker. It's got Bluetooth there. Curved lines give the sense of freedom and soothing move. Think about things that you see. Have you seen a chair similar to this one up here in the upper left-hand corner? Yeah, maybe. Okay. The water bottle, of course, has some curves in it right here. All right. Shapes, they are 2D areas enclosed by lines or curves. And there's different types of shapes. There's geometric shapes. Those are things like squares, circles, triangles, stars, octagons, rectangles, I think I already mentioned. But anyways, then there are mechanical shapes. That's like this bicycle chain here, okay? There are simple shapes that are made up of straight and curved lines. Those are mechanical shapes. Then we have organic shapes. Those are shapes that occur in nature, leaves, trees. Those are organic. This is a BMW car. You can tell it's a BMW. BMW has a particular, what they call design language. Every BMW that's ever been produced, as far as I know, has always had what they call the kidney-shaped grills on the front of it. My wife has a BMW that's a 2004. The grills don't look exactly like this, but something similar. Okay. So we have a car with this. I believe this looks like a concept sketch for the Bmw i8, which is their gas/electric car, or electric/gas car, I think is probably a better way to put it. It's their quote unquote supercar. It has a 3-cylinder engine in it that runs a generator that produces power for the wheels. The wheels are powered by electric motors. They are not powered by a gear train coming off of the electric motor. They've also just discontinued it with this model year, I believe. Form, that is another one of our things we need to talk about here. And form is a 3-dimensional volume or a solid. And it's also implied on a two-dimensional surface by the careful use of value. That's the white and the black in it. And then you can see this, like, I guess that, I was going to say it looks like origami, but it's definitely too thick for that. I don't know what that would be made out of, some sort of plastic. Color, that gets described by a number of different quantities or qualities. Hue is the base color. So what is it? For example, red. Red, green, blue, those three colors that I told you about that we have for our plastic, those are the base colors, okay? Then we have value. That's how light or dark it is. If you look, you can see something's red, but it's a dark red versus a light red. And then saturation is about the purity or the intensity relative to gray. Temperature colors. What color on a faucet, when you look at it, what color do they use to indicate hot water? Red, right? Well, that's a warm color. They're telling you on the faucet that that water is going to be hot or warm coming out. Oranges and yellows, those are also warm colors. Think about fire. Fire is typically represented by red or yellow or orange even colors, right? Then we have cool colors. Again, on a faucet, the blue color, that's going to be cool. And those are things like blues and purples and greens, stuff like that. So color has an immediate and profound effect on design. iPhones were black, and that was how you got them for many, 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 many years. And then they came out with this version of the iPhone, and they had 5 different colors. You'll also see plastic bottles occasionally have different colors attached to, the colors are going to give you different feelings when you look at them. Value is the relative lightness or darkness of a color, an object, or a shape. We see these rubber duckies here. We have a higher value for this darker one, this one on the left. In the middle, we have a medium value. Then on the right, we have a low value, and that gives us that lighter color. Value allows us to perceive shapes and the illusion of three-dimensional objects on a 2D surface. Texture is the surface's look or feel. And there's different kinds of textures. There are smooth textures. Smooth items are going to reflect more light. They're more intense in color. And then there's rough textures. They absorb light and they appear darker. So here is a smooth texture on the cell phone in the upper left-hand corner. The right-hand corner has a fuzzy mitten or something. I don't know what that thing is. And maybe it's a rug or a blanket, whatever. And then, of course, we have that brick wall. You can run your hand across it and you can feel the material. So that people use rough textures to indicate strength also. Space is the area between and around parts of an image or the implied depth of that image in that image. And there are positive and negative spaces. So in these physical balls, you have positive space here because that's what's filling in this circular area. And then over here on the left, you have negative space, and that's there because it has this blank area in it. Space is evident in images that have depth. So there's different types of space. There's open and uncluttered space. And then there's cramped and busy. So what kind of space do you think we have here? In this picture on the right-hand side? Is this open space or is it cramped and busy? What do you think, Braden? You think it's open? Okay. Anybody here think it's cramped? I got to be honest with you. I would go with cramped because it's got a lot of stuff there, right? Lots of different textures and types of brick and stuff. And my answer is no better than his. Okay. His answer is just as good as mine. It's a matter of opinion. It's how you perceive things. Okay. So I can't look at something and have you give me an answer and tell you you're wrong. You're not going to be. It's what you see. Here's another one. Space is evident in images with depth. There's the open and uncluttered, and there's cramped and busy. So, Connor, what do you think? Cramped and busy or open and uncluttered? Cramped and busy? Show of hands. Who thinks it's open? No? Everybody thinks it's what'd you say, Connor? I'm sorry, I lost track already. Cramped and busy? Okay. All right. So it's all a matter of your thoughts. All right. So those are the elements of design. And when we come in on Thursday, we're going to pick this up with the principles of design and what those are so that you can start working on your nice sketch of your nameplate. Okay. All right.